Hey everybody, this is Larry. This is day 11 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button. Join me on Discord. Let me know what you think about today's poem, Sum of Root to Leaf Binary Numbers. Okay, so you're given the root and then sum of the root to leaf. Okay. So what if it's not a complete tree? Is it always a complete tree? I wish they had one example that tells you whether it's a complete tree. I mean, I think it doesn't really matter, but yeah, but this is just this is a easy problem, and I'm not saying it because I think it's easy per se, but it is labeled as easy, as a problem labeled as easy, and it is a good practice for recursion, trees, and maybe a little bit linked lists if you want to think about it that way. So I think about trees as kind of more complicated linked lists, kind of. So definitely make sure you understand how and why, and don't look at solutions until you. I mean, do as much as you can before if you need help on this. But it probably doesn't really get that much better or that much easier than this one for trees. This is a very, I think there is a little bit very minor thing to kind of do to get the numbers, but other than that, it should be okay. And let's do this together. Let's have a function called total. You have a node and you have a current sum, right? So let's do it, right? If this is a leaf, then we are done. If this is, right? Yeah, leaf. Okay, so if well, let's just do very quickly. If node is none, I think that we should return 0 because I think that's a little bit awkward. But if this is a leaf, which means if node dot left is equal to none and node dot right is equal to none, then we just return current as we do it. And then otherwise we have so we have, I don't know, t is equal to 0 or t is equal to total of node dot left current. So I think for this particular part of the problem, try to think about when you go from one step higher to one lower recursion. What does that mean, right? That means that the relationship behind it and how you call those functions. And for me, it's just about shifting the digit 1 over and then adding the next number to it, right? So that's basically the idea I would have. So this is plus node dot route. Plus the other side, right? Node dot right. And then that's pretty much it. So I guess I don't really need this. But yeah. And then we just have to kick it off at the root and 0 to begin. I think this should be okay, maybe. Let's see. Oh, yikes. Why is this wrong? Dong, dong, dong. Oh, actually I messed this up because current is not the sum of this. It is the base case would be that node dot value does have a value. So then now you return the current times 2 plus node dot value. Okay, whoopsie daisies. And of course you can maybe in current is equal to current times 2 plus node dot value. Maybe that's a little bit better. I don't know. Because we use it in a lot of places. But yeah, as you can see, it's still possible to make mistakes. So even though it's easy, make sure you test. Make sure you have more comprehensive tests. And for me, I do want to add a thing where it's a non-complete tree. Do they want no or none? I always forget the syntax for these. There you go. Something like that, right? And then just to see whether we would still get the right answer, because all this is complete tree, so I wanted something not complete, right? So it still looks okay, so let's give it a submit. I guess 2 years ago or whatever it was. Wow, that is a long time ago. But also I did it in PHP, so I don't feel that bad that I got it wrong. Initially I was like, oh yeah, I got it wrong. That's a little bit sad. This is not that bad. I should have at least tested, but it's in PHP, so I think I probably did it on stream to just like just for fun and just to see what happens. Yeah, 651 day streak. Let's go over the complexity really quickly. Ooh, let's turn this off. How do I turn this off? Yeah, so we look at each node once, right? So this is going to be linear time because we look at every node once, so that's just linear time, right? And in terms of space, there is the stack space. So if you think about if you have a linked list of a tree, it's going to build on all that stack, and as a result, it's going to be linear space. Yeah, I don't really have anything to add to this one. I mean, I think you just need to practice it if you are struggling with it. I'm curious what I got on the PHP wall. Oh, I didn't convert it to I did it in a kind of funky way, but I divided by 2 instead of adding an extra check, so I was a little bit lazy there. And of course Python, I just like, yeah, I made it not lazy, and this was okay. But yeah, and this is in PHP, just so that, you know, tooling doesn't matter too much per se. In fact, it went way faster than my Python solution if you needed something. But yeah, anyway, that's all I have for this one. Have a great rest of the week, or I'll see you soon. Stay good, stay healthy, to good mental health. Bye bye.